All right, we are in section 13.6, where we're going to use uh, measures of central tendencies and dispersion. Okay, so first off, we got to know what the central tendencies are when it comes to looking at uh, like averages and being able to figure out how to organize our data. So we have three terms that allow us to find the central tendencies of a certain data set. The first one is the mean. The mean is probably the most common uh, central tendency because it tells you the average of the numerical values in the data set. Okay, and it's denoted as x with the horizontal line segment right above uh, that said variable. So if you ever see that, that's what it means. That's what it means. They're talking about the mean of uh, the data set. The next central tendency is the median. The median is the middle value when data are ordered in numerical order, so from least to greatest. If you have an odd number of data sets, it's always going to be that middle term. If you have an even number of of pieces of data, what you're going to do is you're going to take the two middle pieces and then find the average of that. So you're going to use the mean for uh, that particular set to find the median. And then finally, we have the mode. The mode is the value that shows up the most frequently in the data. Now, you can have one mode, which means you have one particular set of data that repeats itself, and it's the only one that repeats itself. You could have no mode, which means you have no values in the data set that repeat itself, or you could have more than one mode. So you have multiple values that repeat, and which means you'd have more than one value that represents the mode. So start looking at some examples. And in this case here, it says the length in miles of the 10 longest rivers in the United States are listed below. They want us to find the central tendencies. It says which of the measure of the central tendencies best represents the data they want us to explain. So first things first, let's find out the first one. So we got the mean. So in order for us to find the mean of this particular data set, what we're going to do is you're going to take all of these values and add them together. So you go here and I got 1290 plus 1310 plus 1420 plus 1450 plus 1460 plus 1900 plus 1900 plus 1980 plus 2340 plus 2540, and it's going to be all divided by the number of pieces of data. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then it's all divided by 10. If you were to add up all 10 values in the numerator, you get uh, 17,590. And then so that gets divided by 10, which means that our mean in this scenario is 1,759. All right, so that's the first central tendency to look at is the median. All right, the next thing we got to find, or I'm sorry, is the mean. Now we have to find the median. So we got here. So the first thing we got to look at is our data set listed from least to greatest. And in this case, it appears to be so. 1290, 1310, 1420, 1450, 1460, 1900, 1900, 1980, 2340, 25. So it's listed in order. So now what we have to take into account is we have an even number of pieces of data. So that means that we're going to take the two middle pieces. So in here we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my two middle pieces are 1460 and 1900. Because we have the even number, we have to look at the two pieces here, and we have to find the mean of the two middle pieces to get the median in this scenario. If it was an odd number, we would just pick the middle one. So now I go over here, and this is going to be 1460 plus 1900, and it's divided by 2. So I got 1460 plus 1900, divide that by 2. I get a result of 1680 as my median. When it comes to mode, all I got to do here is um, figure out the ones that repeat the most. And I have two repeated values here of 1900. So we do have a mode. It's the only one that repeats, and that is 1900. So we have a mean of 1759. We have a median of 1680 and a mode of 1900. So now what we have to ask the question is which measure of the central tendencies best represents the data? And a lot of times it's probably, unless you have really big uh, outlier values on for the least value and the greatest value, for the most part, it's probably going to be the median. The mode is, you know, it's not that much larger than the mean. Uh, our median's pretty close, so I would say that our median would be the best representation for this central tendency. Okay. All right. Now we're looking at measures of uh, dispersion. So it's the spread of the data. First thing, one of the terms that you're going to be looking at in order to solve, you're going to look for the range. The range is the difference of the greatest value and the least value uh, in your data. So you take the largest value in numerical order, subtract it by the smallest value in numerical order, and you get your range. And then the next term we have here is the mean of absolute deviation. Mean absolute deviation is the average distance of each data value to the mean of the data set. So it's given by this. So it's the absolute value, so whether it's the difference of the first value subtracted by the mean, and because it's absolute value, that means your result is always going to be positive, and then it gets divided by the number of values in the data set. So that's what n equals, number of values in data. So like up above we had 10, so that's why n would be 10 in that scenario. Okay, so we have, it says the top 5 finishing times in seconds for swimmers in two women's races are given. The times for the 50-yard free are in set A, and for the 100-yard free are in set B. It says compare the spread of the data for the two sets using A, the range, and B is the mean of absolute deviation. So first off, let's look at set A. Let's find the range. So anytime you're going to be looking at these different sets, make sure that they're in numerical order. So 24.32, 24.34, 24.48, 24.82, 25.02. We're good there. So to find the range, you are going to take your largest value, which is 25.02, and subtract it by the smallest, 24.32, and that's going to be equal to 0.7. So my range is 0.7 in set A. Let's look at set B's range. So 52.9, 52.96, 52.98, 53.02, 53.24. Largest value 53.24 subtracted by 52.9. The difference there is going to be 0.34. So that's the range in set B. So now we got to go, and in order to find the mean of absolute deviation for set A, we got to find the mean first. So finding the mean. So what we're going to do is you're going to take 24.32 plus uh, plus 24.34 plus 24.48 plus 24.82 plus 25.02, and then that gets divided by 1, 2, 3, 4. There's 5 values in the data set. Divide that by 5. So rounding it to 2 decimal places, the mean in this case is 24.60. So I go here and writing this out, you are going to take the first value in the data set and you got 24.32, and you're going to subtract it by the mean, which is 24.6, plus the absolute value of 24.34 subtracted by 24.6, plus absolute value 24.48. Oh, shoot, needs to be subtraction. 24.48 minus 24.6 plus uh, absolute value 24.82 subtracted by 24.6 plus, and then absolute value 25.02 subtracted by 24.6, and that's going to be all divided by not 10. 10 was the other value. By 5, because there's 5 in the data set. So we look at these different absolute values. 24.32 minus 24.6 is negative 0.28, but because that's the value, it's positive 0.28, plus 24.34 minus 24.6, that's negative 0.26, but positive because of absolute value, plus 24.48 minus 24.6, that's negative 0.12, but we got positive because of the absolute value. 24.82 minus 24.6, that's positive 0.22, plus, to finish up, 25.02 subtracted by 24.6 gives me a positive 0.42, and again, this is all divided by 5. Add all these up and divide it by 5, we get a mean of absolute deviation. My value is going to be 0.26. And looking at set B, so we've got to find the mean for this. The mean is 52.9 plus 52.96 plus 52.98 plus 53.02 plus 53.24. Divide that by 5. We get a mean of 53.02. Okay, so now when you subtract the mean to each value in the data set, taking the absolute value, in this scenario, we get 0.12 for the first one, plus 0.06 second one, plus 0.04 for the third, plus 0, plus 0.22. Divide this by 5. We get a mean of absolute deviation, and that's going to be equal to 0.088. Okay? And that is how we use measures of central tendencies and dispersions. Hope this helps. Until next time.